All right, so we're going to get started today with exercise 217, and I hope today is actually fun for you. The goal today is to learn how to take your skyscrapers and make them into physical objects, and so that's hopefully the point. 3D printing has evolved since I started 3 semesters ago. Daniel came to me and said, "Guess what? You need to teach 3D printing in your class now." I said, "Oh, really?" And he said, "Yeah, you do." I said, "Okay, well, somehow I got to figure that out." So the 3D printers are, by their nature, finicky. It is what it is. There is currently 1 3D printer working. Good sign for us. At least we have 1. There are 4 in the lab. So, hey, 25% working. All right, we'll take it. The Type A machines, which I consider to be very good at doing the 3D prints. The company apparently couldn't make enough business, so they went out of business. So we're kind of stuck with those machines with no support, so I don't know whether the other machine will ever start working again. I know David spends time playing with them when he has free time to try to see if he can get it to work again. Let's hope that we can get that one working, because I actually do like them. I think they do a great job. So anyway, I'm going to pass a few of the 3D prints around. 2 of these are partial prints that errored, and that's why I'm still left with them from last semester. Sometimes they're just an extra print altogether, but you guys can see what they kind of look like and that sort of thing. So today we're going to talk about making them. We're going to do 3D prints and getting your file ready to 3D print. We're also going to talk about unrolling surfaces, and so I have a whole nother set of things that I'm going to pass around. These are all folded paper models or cardboard models based on unrolled surfaces. Now the good news for you guys is you don't actually have to make these. I cut that part out, so you're safe. You don't have to make these. That's good. However, we're going to try to do the 3D print, and fingers crossed that somehow we'll make that happen. In terms of grading for your assignment 203, however, I'm not going to grade the final 3D print. I'm going to grade that you were able to create the G-code to make the 3D print, but not the actual print. And that saves us in case the 3D printer dies or something like that. My goal and my desire would be for every one of you to have a 3D print of your skyscraper. That's what we're shooting for. But I can't make that promise knowing the way the 3D printers work. So we're doing the next best thing. So I will also pass these around because it will help you see how the unrolled surfaces work in Rhino. I've got a bunch of them, so you guys can play around with them. Obviously, there was a time where I did have people assemble these. So today we're going to do 2 different things under part 1 and part 2 of your exercise. So it's kind of split into 2 halves. The first part is the unrolling surfaces. This is if you were going to take your model, flatten out the surfaces, and cut tabs and glue it back together, kind of like you did in 130 when you created those shapes with the little tabs and then you put them together with tape, etc. We're going to do that digitally. So first thing I'm going to do is I'm going to open up Rhino, and I'm going to go back to my skyscraper file, my original skyscraper file, and I don't know which one it is, so I'm going to go in and actually open it. And we did this in exercise 214. And so I'm going to go ahead and open the skyscraper. This was the skyscraper that I created. I subsequently used this as a block. So the good news is there's not the city of San Francisco in anything. All we need is the block file. And at this point, I'm going to switch over into shaded mode so we don't see the textures anymore. All I really need are the outermost surfaces of this object. All of the floors aren't going to help me too much in terms of this unroll. So I have 2 options. The first thing I can do is just do a save as, so that I'm working on a copy of my file. Or I could select all of the outermost objects. So in this case, the skin, the top, the bottom, the lower skin here. Oops, not that. Like that. That should be all of my objects that are on the outer surface. And if I have all of those objects on the outer surface, I can go to File and then Export Selected, which will just take those pieces. And I'll just exporting as another Rhino file. So let me put it into today's folder. Then I'll go ahead and save it. Then I need to go open it, the exported file. So it was in today's folder. And there it was. And if I did it correctly, I should get none of the extra stuff. I shouldn't have any of the surfaces, any of the floors, any of the ceilings. If I look at my layer stack, I do have a couple floors here, but it's only the top and the bottom, which I exported with it. This is pretty close to what I'm going to need to create this, this shape. Now that I have this, I'm going to do two different things, and this is where part 1 and part 2 comes into play. The first one is about unrolling the surfaces. So this first one is, what if I wanted to be able to lay this flat, laser cut it, and then glue it back together, like those models have been glued back together. And so we want to be able to create that from our existing object. And this is something that you can do in Rhino relatively easily. The only point that you guys are going to get stuck on, if you get stuck at all, is if you have curvature in 2 directions. And so essentially curvature in 2 directions would be, I don't have any on this one, but it would be like having a sphere, where it's curving this way and it's curving that way. And so if I wanted to take this and I wanted to unroll it, kind of like peeling an orange, I couldn't do it without breaking it and creating some seams. So if I went into the Unroll Surface command, which is what we're ultimately going to be doing today, it's under Surface, Unroll Developable Surface, right here. It's also, the key command is Unroll SRF. And if I do that, it's going to say unrolling doubly curved surfaces will produce inaccurate results. Okay, so there's where it's saying, can't do it. If you end up with that, even if it was unintentional on your model, you're going to have to do a slightly simplified version of your model. The strategy there, in all likelihood, is to duplicate your edges and pick the edges that run down the outside of your building, like this. Again, mine is not doubly curved, so I don't really need to do this, but I'm showing you for those of you that run into that problem. So I've picked all of the edges of my building. I make curves by hitting enter. Let me move those over so you can see them. There they are. And then I'll take the adjacent curves, so this to this, and loft. Then I'll take this, and I'll loft. And that will create developable surfaces in between each of these curves. This is only necessary if you have double curvature. So if you try to unroll the surface that says I can't do it, this is where you can do that. And so you'll end up with a slightly simplified version of your final building, which is fine. So in this case, I don't have it, so I'm not going to worry about unrolling the doubly curved surfaces. These will, in fact, unroll correctly. So before I actually do it, however, I want to go through and I want to join everything together. So right now I have this upper section and I have this lower section. Let's take the upper and lower and join them together. And that creates one polysurface. Likewise, I'm going to want to join in the top here. And that box isn't quite ready yet. I can join in the top to my building there. Now that's joined in. This is a little bit more challenging because I created a box when I did it. So it has a bottom on it right there. I want to get rid of the bottom, so I'm going to type explode. And there's the bottom. I can get rid of it. And now I could take this and all of these sides and join those together. Now all of that's joined. I can come down to the very bottom and select this one, and I could join that together. Oops, there we go. Join. Sorry, join. There we go. And so I was able to join all of those together. I'm not overly worried at this point about that hole in the bottom. It can stay there. It's fine. So now that I have all of my object nicely joined together, it's time to actually unroll the surfaces on this object. Before I do that, it's useful to create a new layer. And let's make it outside of the skyscraper layer. And I'll call this layer Unroll to help keep myself a little bit organized. I'll make that the active layer. And now it's time to do the unroll surface command on this object. So I'm going to go up to my surface, and I'm going to come down to Unroll Developable Surface, or type Unroll SRF. And it's going to ask to select the surface or polysurface to unroll. So that would be the surface or polysurface to unroll. I have some other options. Explode, yes or no, and labels, yes or no. Depending on the complexity of your object, you're probably going to end up having to explode the object. So we'll leave that one set as yes. Labels, unless you're really good at figuring out how the puzzle goes back together, give yourself some labels. So I'm going to turn the labels to yes. That's going to help a lot. Keep properties set to no, that's fine. It also asks me to select curves on the polysurface that I want to unroll. If I had all the floors, I could unroll the edge curves of those with it. And I'll show you that in a little bit, just so you can see what it would do. But for right now, I'm not going to worry about it. So I'll go ahead and press enter. And when I do that, it gives me a set of labels on my building. And it also gives me all of the unrolled pieces that I would need to assemble this building. The numbers match up, or at least they should. So for example, with this very top, I can start to look at the top, and I can start to look at all these pieces. We know that this creates a box, so I can start to assemble this. I can go to move, and I can move 3 to 3. Furthermore, I could rotate the 3s to match up along that edge, because ultimately they would get folded right there. I could take the 2s, and I could rotate that 2 to fall right there. I could take the 1 and then rotate, and I could take the 0 and I could move that there. So that one's now ready to build at the very top. I need to do the same thing for these bigger pieces. So let's start. I'm going to start with this one here. Let me move it out of line for a second. There it is. And so this edge here is 17. Right up here, there's 17. Let's move. And then rotate. And now 17. Oops, didn't quite do it correctly. And I didn't quite snap correctly. There we go. They should match up perfectly on either side. If they're not matching up, you did something wrong. Looks like my rotation is still off. There we go. So then I have 16. So I'll look for 16. There's 16. We move 16 to right here, and then rotate again. There's 16. 15. There's 15. I can rotate 15 to be right there. Okay, so now I have a problem. 13 here doesn't work because I can't have the two pieces overlap. So we'll come back to 13. Let's go to 19. There's 19. And then again, I'll rotate that. And I have 18 here. And there's 18. So I did fairly well, except I missed piece 13. So we'll come back to that in a second. Let's take the other, let's see, the bottom here, we've got 29. I thought I just saw 29. Where was 29? I deleted it. Whoops, sorry. 29 goes to 29. 22 goes to 22. 14 goes to 14. Five. And 21. And 20 and 20 match up over here, but I still haven't figured out how to put them in just yet. And so we're getting to that. But I can put them together. Now I could take my piece here, for example, and I could say, okay, where is piece, let's see, let's go with piece 33. And I'll put it to there. I'll rotate like that. And now I should be able to take piece 32 and put it on 32 and rotate 32 to right there. And so that piece will end up folding in between these two pieces, but I can cut them out. So this then, except for the very top right here, 6, 7, 8, 9, 10, 11, which corresponds to 6, 7, 8, 9, 10, 11. There's no way for me to put this in there. I can't cut it out. So this would have to be, in this particular example, this would have to be a separate cutout right there for me to be able to assemble it. This then, if I took it to the laser cutter, theoretically is the pieces that I need to unfold. Now, it's not ready to cut yet. I don't have red and blue lines. And so one of the requirements for your assignment is to actually get it ready to cut. You don't have to cut it. You don't have to glue it together, but you have to get all the way to be able to cut it. And so I'm going to create 2 new sublayers. Actually, you know what? Let's make it, instead of 2 sublayers, let's just create 2 layers. I'll call this laser cut. And I'll create a sublayer for cut and another sublayer for engrave. So what I need is I need curves that represent the outside edges of all of these pieces. And so I could type in dupe edge, and I can work my way around the edges. I could type in dupe border, but I'd end up with double curves where I have 2 surfaces. So I'd end up with 2 curves right there instead of 1. So I like the dupe edge command a little bit better because you can specify each edge only one time. And I apologize, this is the kind of thing where it always takes time. No matter how fast I can be, it takes time to go through and select all of these. I'm going to ignore the little top piece for now, and I'm not actually going to cut it out. Okay, so I've worked my way around the whole building, and I'll go ahead and press Enter. But before I do, let me put it on the cut layer. Let me change my active layer to cut, and I'll press Enter. And I can now turn off the unrolled surfaces, and I'm left with just these pieces. Oops, looks like I missed one at the very end here. So dupe edge, that one, and we'll change it to be on the cut layer. And we can turn off the unroll. I can also take all of these and change that cut layer to be red. They'd be ready to cut out. And the engrave layer we can change to be blue. All right, that works. And actually, for simplicity's sake, I think the easiest thing would be to start working in the top view. All right, so let me take all of my objects, and on second thought, I think I'd rather have them on the engrave layer because most of these lines are going to end up being engrave lines. So we'll change object layer, and they're all in the blue. Now, in order for these sides to glue together, I need little tabs to glue. I need some space to overlap and glue, so I'm going to create those right now. So I'm still active on the cut layer, and I'm going to do an offset. And I don't know what the distance is going to be because I haven't scaled this object yet, so I'm going to say that my distance should be, I don't know, about that much, whatever that is. It looks about right if I was thinking about building it in a model. So I have the distance set, and I'm going to offset this side here, but I'm not going to offset the opposing side here. I don't need two tabs, I just need one tab. So I do it on, say, this one, that one, that one, and that one. I wouldn't need it here and here. I would need it on the end. There's one on the end. And if I did it on this one, I wouldn't need it on this side. So we're good. So on this one, I wouldn't need it here or here. Furthermore, I don't need it along the bottom because I already have it. I don't need it on this back edge because I already have it there. On this edge, that would match up to this bottom, so I don't need it there. I don't need it on this edge because that matches up there and there. I would need it on this bottom. And now I have to decide. It's either going to be on this or it's going to be on that side there. And I can take my pick. This starts to get a little pinched, so I'm going to ignore that side and I'll do it right here instead. And it should be on this bottom there. And it's going to fold up and glue to there, and I need it on this side as well. Perfect. So now I have the tabs that I want. So you kind of have to mentally go through and see how does that fold up and where does that piece belong. So now that I have the tabs, it's still time to do a little bit of cleanup work. I'll go into my polyline tool, and I need to connect the tabs where they split. Likewise, I need to connect that piece there so it cuts out. This one overlaps that base, so obviously I don't want to cut it all the way to there. So I could just end the cut right there. Let me go ahead and trim, and we can end it right there. I'll go back to polyline. I'll make this one. That looks pretty good. Same thing here. That one's really close, so it's probably going to end up being trimmed. So we'll trim it. There we go. Same thing on this side. We're going to just trim that off. Go. Those two overlap, one or the other, or we could trim them first. And then go to where they connect. The tabs, of course, don't have to be perfect because you can adjust them afterward. You can cut some of it off if you need to. Missed that one there. A little bit more at the top here. Okay, so now that I finished the tabs, I need to go back through and make sure my shape gets fully cut out. So obviously my cut's going to go around the outside. The blue lines are my engrave, so that piece is fine. This piece, I need it to be cut out. Likewise, I need this piece to be cut out. That and that also are cut out, so I'll change those to the cut layer. Don't need to worry about those. That's cut out. This would be cut out. This would be cut out. That would be cut out. As with that. Now this and that would all be cut out. And I'm missing those two lines there and there. And like I said, I'm skipping the little cube that goes on top. It's more pieces and I can't glue it in. But essentially, this then is ready to go get cut out. And all the blue lines would be fold lines. All the red lines would be cut out. And I'd be able to walk over and laser cut this. And if I was really careful, if I glued it together, I could create the same shape that I just created, or that I created in Rhino. So it takes a little bit of work to get this ready. This is what I'm looking for as part of your assignment. It's also what I'm looking for when you're done today. This is one of the two things that I want to see. So you'll create this ready to be unrolled or ready to be cut out and reassembled back together. At this point, if I were doing it, I would scale it to the correct scale so that it would fit on the laser cutter bed, and I would select it and do a file export selected and turn it into an AutoCAD file. The rest of the laser cutting process is exactly the same as what you guys did when you cut out the topography. So this is prepping that part of the file. In terms of what you turn in, I forget whether I asked you to upload the AutoCAD or not. I don't need the AutoCAD. All I need is a screen capture of this showing the red and the blue lines. That's the part I'm interested in for today. So that's part one. That's unrolling surfaces and ultimately being able to build a paper model out of your project. And if I were doing this, some of the paper that they used that was passed around was a little bit too heavy. A watercolor paper, like a 140-pound cold press, is just about the right paper to have enough flexibility in it to create the shape that you want, just from experience. Like a 2-ply, it might work, but it's a little thick and a little harder to get it to twist. Depends how much you're building twists. But it is doable when you glue it. If you're careful and you align the pieces, you will create the twist as you glue it together. So I was able to create the laser cut. At this point, I can turn off the laser cut layer. Oops. Let me go back to my skyscraper layer here. Let's turn off the laser cut layer. Let's turn off the unroll. We can turn off the unroll. And then we go back to the perspective view. So the next half of what we're doing today is creating the watertight model to build a 3D print, or to create the 3D print. And so I actually very recently just published a few tutorials for you guys on this. Like I said, it's relatively new, so I'm working through it. It's only my third semester into it, so bear with me if I made a few mistakes. If you go to the tutorial section of the website and you go to physical modeling and you go to, let me refresh this. Uh, 6.5, 3D printing from Rhino. This will walk you through the 3D printing part. This first part, steps 1 through 6, is very close to what's on your handout for today. But then we get into Cura and some of the more advanced stuff, and so you'll want to refer back to this particular tutorial. So in terms of prepping your file for 3D printing, I suggest you do the same thing that you did in the first round, where you isolated your objects by doing an extraction, essentially, an export selected of just the skin of the building and whatever's on the outside of the building. So I'm going to close this just so I get a fresh start. You don't have to, but for my purposes, I'm going to do a fresh start. Actually, I'll do a file save as. Call this one 3. And then I'll go back to version 2 here. So this is where it was when it first came in, after I did the export. So I'm trying to make it match up to what you guys are doing. So the goal here would be to 3D print this object. Now, when I do 3D printing, I need this object to be what is called watertight, or the 3D printer won't like it and it won't print for me. And what watertight or a watertight object means is that there are no edges that aren't joined together in the model. So for example, if I had a box that looked like this with no top on it, and I went to go 3D print this object, these planes are infinitely thin. They have no dimension. They have no thickness to them. And the 3D printer would say, well, I can't print that. I can't print something that's infinitely thin. They need some kind of a thickness. So if I wanted a hollow object like this, I would have to add thickness to the walls of the object to create the thickness so that it could 3D print. Or if I wanted this to be a solid object, I would have to have a top on this particular object to allow it to print. Even if I went to join, it's still open at the top, and that presents a problem. So the good news for us is that Rhino has a command that's built into it that can help us find where the errors are. And it's a command that's called show edges. And if I type in show edges, it's going to say select surfaces, polysurfaces, or meshes for edge display. I'm just going to type in all, so I have everything selected. And I'll go ahead and press enter when I'm done. It brings in this edge analysis dialog box here. And so on the edge analysis dialog box, we have the ability to show all edges, naked edges, or non-manifold edges. What we're interested in are the naked edges. Naked edges are edges that aren't joined to anything else. So you can see that when I have all edges showing, it shows me all of the edges on these polysurfaces that go around my building. But when I switch to the naked edges view, those go away because these are joined together. So this is one object. This surface here is joined to that surface there. So with this naked edge analysis showing, as I start to work through this, if I took this object and took the top surface and joined them together, the naked edges that were running around the outside there have gone away. Likewise, I have naked edges running around here, there, and there. I really should change this color so that you guys can see this a little bit better. Hold on a second. You can see the naked edges at the center. And so if I took this object and joined them together, that naked edge there goes away. So with this naked edges active, it's pretty easy to look through and see where are the errors in my project. So down here at the bottom, I could take this and I could join the bottom surface in, and I'm left with that hole. No other naked edges, just that hole. So in order for me to be able to 3D print this object, I need to fill in that hole. So I'll go over to my surface tools, and I could do a surface from 4 corner points. I could do a rectangular surface, there to there, for example. Then I could take my 2 objects and I could join those together. Oops. Helps if I type join correctly. And now those are joined together and the naked edges go away. So this top one is a little tricky because remember I had this sitting on top of my building. If I were to hide this, we'd see that inside hole is still there. So technically speaking, this would work and it should 3D print because this is coplanar with that. I get a little nervous about that. So I'm going to take this object and I'm going to explode it. I'm going to switch into my ghosted so that I can kind of see through and select what's on the bottom there. There you go. There's the bottom one. I'm going to delete it. And now I'll take this object and join it to the rest. And so now it's hollow on the inside. If I were to jump myself inside, there we go. And cut out that way. Do you guys see how that works? So I now have an object that is watertight. I have no naked edges. This object over here still has the naked edges, but that was my sample anyway, so we can get rid of it. Sometimes you've created new objects and you need to add objects to your selection to show the edges. So it's always good when you think you're done to click on Add Objects and again type All to make sure that any new objects that you created are still part of the selection, which I did. Yep. And so everything is joined together and there are no naked edges. This then means that this object is ready to be 3D printed. So the first piece of this puzzle is to make sure that there's no naked edges and it's ready to 3D print. It's a shell. It's a shell here, but it's a closed polysurface. There is no thickness to it. It's infinitely thin. It's as if it were a solid. I guess I should. You could describe it as a solid, but it is technically it's just surfaces on the outside and hollow on the inside. But the 3D printer, because it's a closed, watertight no naked edges object views it as a solid, and it's going to print it as a solid.
You're like gonna ask about that. So basically, you're like putting a cap on it. You're like makes the 3D printer think it's solid.
Exactly, exactly. So technically speaking, NURB surfaces can't be solids because of the mathematical definition. They're only surfaces. They're just joined together polysurfaces. But from a 3D printer standpoint, it's going to view this as if it were a solid object. So it's going to fill in the inside of this with a solid. So now that this is ready to 3D print, it's time to move on into actually building the file that we can generate the G-code, which we can then generate the 3D print from. So there's still quite a few more hoops that we have to jump through. So the 3D printers don't like NURB surfaces. We just talked about them being a surface on the outside, not a solid on the inside. So we need to convert this object into a mesh, because that's what it's looking for. And if we didn't convert it into a mesh, when we did the export to STL, which we're going to do, it would force us into creating the mesh anyway. So we're going to go ahead and select that nice closed surface that we just created, and I could actually create a new layer altogether called mesh. Put it outside, double click so it's active, and I'm going to select this surface and I'm going to type in mesh. The mesh command converts my nice beautiful NURBS smooth surface into a series of triangles like the SketchUp terrain, where it's a triangulated faceted surface. The cool thing about it is I have the ability to choose how many polygons I want to make up my surface. So I would always turn on the preview by clicking preview, and you can kind of look at how it's divided up. Can you guys see that? Yeah, you can see that, into all of those polygons. If I increase this number up and I preview it, they get much tighter, the polygons, and more accurate. If I decrease the number and preview, it gets much more simplified. So depending on your goal, you want more or less. The middle ground is usually fairly accurate to what you want your building to be. If you want to increase it a bit, that's okay. You could do that. When I'm done, I'll go ahead and say OK. And I now have two different files. I have my original NURB surface there, and right underneath it I have my mesh. I'm going to select my mesh and change it to be on the mesh layer, and I'm going to move them side by side just so that we can see them not on top of each other anymore. And let me switch back into my shaded mode. There we go. So there's my beautiful smooth surface that I created in Rhino, and here's my faceted triangulated surface that is my mesh that I'm ultimately going to be 3D printing. It's still close, and it still will read fairly smooth. Though on some of the 3D prints that passed around, you can see a little bit of the faceting on it. And that's the nature of the 3D print. You're still going to get the bulk of what you want out of it. OK, so I now have that file ready. I'm going to move that file. Let me turn on my object snaps. By the way, when you switch to the mesh, you're going to have to turn on vertex to be able to snap to it. And I'm going to move that to 0, 0, so it's at the origin. I will also turn off my skyscraper file altogether, leaving me just the mesh. I can also close this edge dialog box there. So now it's time to scale this object down to be 3D printed. It's currently the full size of the building. It's 600 feet tall. I can't print 600 feet tall, so we need to scale it down. I'm suggesting, for purposes of this exercise and also for purposes of your assignment, that you do it at 3/4 of an inch equals 100 feet. That means you'll end up with about a 6 or 8 inch tall little object. And that fits rather nicely on the 3D printer bed. The 3D printers here at school, the Type A machines, which is the one that is currently working, will print up to 12 by 12 by 12 inches. So that's your maximum size. So if you have an object that's 14 inches, you're not going to be able to print it. So you've got to keep within the context. Printing something 12 by 12 by 12 would take forever. So smaller objects are good in this case. This, of course, is a tower, so we can't get it too small because then it would break off when we were 3D printing it. So we want some kind of happy medium here. So I've found that 3/4 of an inch equals 100 feet is a decent scale for what we're trying to create. So I'm going to go ahead and scale this object down. So I'm going to go ahead and type scale. And so from this point to this point was 200 feet. So I can take this point to this point and make it 1.5 inches, 3/4 plus 3/4. So I'll type 1.5 inches, and when I hit enter, my object's going to go away. That's because it got so much smaller. But I can zoom and then S for selected, and I can get it right back. So now I have it at the size that's going to be printed. It's probably about 6 inches tall, maybe 4.5 inches tall, something like that. I could type in distance just out of curiosity, and I can measure how tall it's going to be. It's 4.5 inches tall. Okay? This isn't the full height of the one that for your assignment that you'll be creating. This is the practice one. So now that I have this ready, I also need to convert this into the units that the 3D printer likes, which are millimeters. So we need to convert from inches to millimeters. I will do that by right-clicking on the inches text down here at the bottom. I'll go to my unit settings, and under model units, I'll switch from inches to millimeters. When I do this and say OK, it's going to prompt and say, do you want to scale your model by 25.4? You want to, so you'll go ahead and say yes. And then once again, we can Z for zoom, S for selected, and we get our object right there. This file is now in the correct units. It's at the correct scale. It's time to export the file that Cura, which is the software I'm going to show you next, can read. And that is a .stl. Last semester, Cura was recognizing OBJ files, so we could export an object file. The newer version of Cura no longer recognizes those, so we're going to STL files. So I will select my mesh. I'll go to File, and then Export Selected. And we can put it in this folder. That's fine for today. Under the Save As type, I'm going to switch to an .stl, which is right there. And I'll give this file a name. This is Exercise 217 for the fall of 2018 semester. I'll go ahead and click on Save. The default STL export options are just fine, so just say OK. And it then wrote my STL file. So this file is what we needed to be able to do the 3D print. And you see that there's lots of steps involved in actually getting something ready to 3D print. Unfortunately, that's the way it works. So I have that all ready to go, and I've made it to about here. Step 6. There's still a lot more to go. So it's all written out here, so you don't have to worry about it. But this is the next half of what we need to do. On your desktop, there's a program. This is free. You could download it on your home computer if you wanted. It's called Cura, and that's what actually generates the code file that the 3D printer needs to build. So we're going to ultimately save something called gcode. It's a series of instructions written in coding language that the 3D printer can read, and it then performs those actions. So we need to convert from the model into this code that we can feed into the 3D printer. This software does it for us really easily, which is nice. So I'm going to go ahead and double-click on this Cura. Unfortunately, again, there's always caveats on the school computer. If I were to just double-click on this, nothing will happen. It won't open. Because for some unknown reason to me, we need to run it as an administrator. So I'll right-click and say Run as Administrator. The good news is you don't need a password or anything. Just say yes, and it will then let us open it. I don't know why. It is what it is. Perfect. And so this is Cura. This is where we set up how we want to build our 3D print. I went ahead and did a few things because I was double checking that it worked today. So let me remove the 3D printer that we have, because if I don't, there we go, it won't match yours. So when you first open, this is what it's going to look like. The 3D printer that we have is not a Utilimaker. It is a Type A machines. We also have a Delta Maker, but I have yet to make that one work. So we're going to stick with the Type A machines for now. If I get the Delta Maker working, I will update and let you pick between which one you want to try to run. So first thing we need to do is we need to actually install our machine into this software. So we have to tell it what machine we're going to use. And so I'm going to go up to the Preferences menu, and I'm going to click on Configure Cura. And in the Preferences here, I'm going to choose Printers on the left side. And I need to add a printer because it's not listed. So I'll click on the Add button. And at the bottom here, there is an Other category. We're going to click on Other, and we're going to scroll through these. These are all the 3D printers that are included with the software. And we're going to look for a Type A machine Series 1 2014. That's what we're going to use to do our cut. And so that's what it is. We'll go ahead and click on Add Printer. And it will then show Type A machines as our printer, which is what it should show. When I'm done, I'll go ahead and click on Close. And now we have our printer bed ready to accept objects. So it's time to load in our objects. I'll go to File and then Open Files. And I'm going to go find my STL file. And so this was the one that I did earlier today, which is the same building, but I'll do the one that we just created. So let me go into my folder for today. There it is. And I'll click on Open. If I did it correctly, my file should show up inside of this space. Same commands work here. I'm right-clicking to orbit, just like the same thing that I did in Rhino. And it shows my little 4.5-inch tall object. It's the right scale. All is good. It automatically centers the object. It's not a bad idea to move your object around a bit to find a spot on the bed that hasn't been printed as much. The center obviously gets the most printing, so moving it slightly off center sometimes is a good strategy. I don't need to do any scaling other than I move the object a little bit away there. That's fine. Now it's time to go through and deal with the setup. By default, your print setup will be in the Recommended tab. In order to speed things up a little bit, I'd recommend switching over to the Custom tab and putting a bunch of custom values in. I will walk you through what all those custom values are as we go forward. Because this is a lot of information to take in, that's where all these screenshots come in. So we'll come down here, and here's all the settings that I want you to change, but I also have it in screenshots so you can see exactly what I'm doing. These are settings that I've found that kind of speed things up and give you a decent quality print. It's the happy medium of time versus quality. So back here, we're going to go through. These work kind of like V-Ray, where there's a bunch of these little drawers that probably will start out closed like this. Essentially, we'll want to go through all the drawers. I'll start with the first one, quality. This is the layer height. This is how thick of each layer of plastic that the printer is going to make. The 0.2 is just fine. We'll stick with that. The next one is the shell. We have two options, the wall thickness and the top and bottom thickness. This is how thick the outside of the object is going to be. We're not going to print a solid object. It's not going to be solid inside. It's going to have a fill structure in it. So the outside is important because we want to make that strong enough to support our object, so it's not squishy. So I've increased this value. I did it at 1.5. And the top and bottom thickness, I also did at 1.5. We'll continue our way down. The next one is infill. The infill density, I do it at 10% instead of 5%. It's a little bit stronger. The 5% is a little squishy. It's just practice. 5% would print a little faster. So there are always trade-offs. The infill pattern, this is what it's filled up with, what the structure looks like inside. You're free to try any of those. The octet is considered to be the best one because it's the most rigid when it's all put together. So we left it as octet. Next thing, we'll come down to material and open that one. We have a printing temperature and a build plate temperature. The printing temperature, I like to bump it up by 10 degrees. It's a personal preference. I've had good luck with it, so I'm sharing that with you guys. So I'll run it at 220 instead of 210. The build plate temperature at 60, that works just fine. We'll move down to speed. I like the print speed at 60. I think the default is 50. It speeds it up just a little bit, and the quality seems reasonable. Next one here is traveling. Z-hop when retracted. I like to turn that on. just in case it needs to move, it's not going to collide with any objects. And make sure it goes up and over and back down. It's rare when you need it, but it's a good habit just in case. Next thing is cooling. I don't think we have to change anything there. Yep, that's fine. Support is next. We want to make sure on support that we're generating our support. So double check that we're generating it, just to check the box. And our support placement everywhere. Sounds good. This is if your object starts to lean and it needs a prop to keep it up so it doesn't fall over. It'll create a temporary little strut to hold it while it prints. OK, we need to scroll down just a little bit. Last one is build plate adhesion. The build plate adhesion type as brim. That seems to be all we need on this printer. You can thicken up the build plate so that it sticks to the build plate a little bit better by changing this to a raft, for example. That's a little bit thicker. The brim seems to work. Essentially, it's one layer of print at the bottom. And you can see it on one of the ones that I passed around that has that little film. That's where it attached to the plate. OK, so once all of those are set up, we can come over here to the Ready to Slice section and click on Prepare. And when you click on Prepare, it will slice up the object and start to generate the G-code, and it will give you a projected amount of time to complete. This is not very accurate. So we'll see over time how accurate this version of Cura is for our machines. I don't know yet. In the old version of Cura, it was about, take this number and multiply by 1.5. And so you'd add some extra time to it. So in this case, it would be 3 hours to run the job. But I don't know on this version of Cura whether they've updated it and it's a little bit better. So once all of that's done, this button that was Prepare changes to be Save to File. This is then the G-code that we need to run the 3D printer. So I'll click on the Save to File button here, and I'll save this as my G-code. And I'll go ahead and click Save. The G-code is the series of instructions that the computer needs, or the 3D printer needs. Let's see if I can open it. So you can see it. There we go. It is the instructions that the 3D printer needs in order to do the 3D print. And so if I were to scroll through this, this is just like any other coding language. You can learn to read it. It's telling the 3D printer where to go and what to do. And so we've got lines and lines and lines and lines of this. It would really suck, for lack of a better term, to create this yourself. So using something like Cura is awesome because it'll go through and it'll build this file for you. Okay, so you can see I've only barely started scrolling. It's really, really long. Okay, so that's all we need to create the 3D print file. From there, it's a matter of actually doing the 3D print. On the website, we got through down to here. Under step 16, I'm in the process of writing up the tutorial for actually doing the 3D print. This is a little difficult. I'd like for all of you to be able to learn how to 3D print. If the 3D printer was more reliable, that would help. Because there's lots of, well, if this happens, you got to do this. And if that happens, you got to do this. So I'm putting this together in the hopes that we'll all learn how to 3D print and solve the problems, and you guys will learn how to 3D print. The worst thing is to have the 3D printer sitting over there with nobody using them. That's worse than even breaking them, in my opinion. Let's try not to break them, and let's try to use them. Happy medium. Okay? So under this Type A machines, I've written out how the job actually runs. So it's a whole nother set of tutorials. I'm sorry there's a lot of steps to it. If you're interested in running the 3D print yourself or learning to run the 3D print yourself, I would love to walk through this with you. I used to be able to open the 3D printer interface from this computer and see what was happening in the other room. We don't get to do that anymore because they isolated the labs separate, so I can't connect to that lab anymore. It is what it is. So this is available for you to browse through. What I'm going to do is I'm going to walk over to the 3D printer room. I did start this job earlier today. I hope it's 3D printing. I kind of hope it's done 3D printing, but I kind of hope that it's still 3D printing so you guys can see it doing its 3D print. So anybody that's interested wants to come over, I'll show you that part of it. The rest of today, in terms of exercise 217, you're doing two different things. You're creating your unrolled surface and you're posting that. I would love it if you could end up posting your STL file and or your G-code file so that you were ready to 3D print. I'm not sure right now if the website will accept either of those files as uploads. I may have to tweak it a little bit to let you upload those files. But I'll double check that after I run over to the 3D printer room. Okay? I know that's a lot to take in, and I know I talked for a long time today, and I apologize for that, but I have to teach you to 3D print somehow. So thanks for bearing with me as we go through it. Okay, so I'm going to stop the recording here. I'm going to go over to the other lab if you guys want to see the 3D print, and we'll see where it is. I don't know, it might be done, in which case I can show you how to start the job. If it's not done, then you guys can see it 3D printing or finishing up the job.